So very excited to be here, and thanks for coming. So we are at Calvio. Calvio is a 3 years old startup in deception, and Splunk is our investor, and we are also a Splunk partner. So I'm going to talk about deception and using a Splunk together to find hidden threats. So here are the three things I'm going to talk about. Number one, hidden threats. Number two, what are the deception, how many of you have heard of deception? Okay. And so I will talk more about deception and the use cases. And then we will get into how do we leverage a Splunk and a deception together to find the hidden threats. So I don't think this audience needs an introduction to hidden threats. It's super easy for anyone to get into the network within a few minutes. We all know that, right? Social engineering and spear phishing gets you anybody, any attacker, novice attacker also into the network within a few minutes. So that's a lost war. As a defender, you have to basically take it granted that anybody want to come within the network, they can just come in. It's pretty much like an open door. No matter what we do, we put IDS, IPS, firewalls, anything we put, they will find the way to get in. The question is what we do after that, right? Once the advanced threats or the adversaries are already within the network, what do you do? What can we do? That's the question. So we need to think differently. Think like it's a chess game, okay? And there is an attacker and a defender game going on. Attacker has undue advantage, we all know that. They know more about us. They know all the tools and tactics what we use as a blue team, as a defense team. And we know very little about them. They are more adaptive. They are more coordinated, than more structured than us. So if we need to win this game, we need to think different. When I say think differently is, can we make harder for them? Can we make life difficult for them? And I'm telling you, this is the paradigm shift. If we can tell them to do more work, right now they can just get in within the network and they can roam around for all the statistics shows, right? The Verizon reports and all that, it shows that they are there more than 200 days. So what can we do? So deception gives you a choice. Think about like this, there are, doors over there. Now the attacker comes in and he needs to get in, right? He doesn't know that which one is fake, which one is real. So if we blend the deception well within the network, we can confuse him, we can delay him. So it's like, in the network, if you got lots of Windows operating systems, Windows workstations, and if we put a decoy, which is a Unix, it's going to stand out, right? And if we use a static host name, attacker will know it, right? And then, he will also put it on a dark web. Hey, this is the old honeypots. Don't go there. And these are the honeypots which are using the MAC addresses like these. And they are using the honeypots, the host names like this. You are busted. We are not talking about the old 90s honeypots here. We are talking about the 2018, 2021, the new technology of deception. Now, what do I mean by that is, if we want to do a deception, it has to change. It's like a magician doing a magic, but then he also does not know what magic he's going to do. So that can be done only when we use the new set of tools and techniques. So how do we do it? Well, we will talk about that, but before that, the key question comes that, why should we do it? And as I said, like the threats which are already within the network, you want to detect the lateral movement. We don't have anything. You have an encrypted traffic, you have IoT devices, hundreds of them, you can't monitor them. The deception gives you a solution. You want to detect the threats within the network, like ransomware and a malware, right? And these are all signature, they keep on changing their signature. They're all dynamic signature changing. Now, if we put any AI, machine learning, believe me, I am an AI scientist and security scientist, and I know inside out about, whatever little I know, they keep on changing, right? So if you put any signature based or you put any machine learning classifier also to detect those ransomware, they will just change it, they will adopt it. And you can only detect only a variant of that. So we need to have a technique, a way which can actually combine, work with other techniques, and then it can improve the deception, improve the detection. So as I said earlier, right, you got a network which has lots of unmanaged devices, encrypted traffic, IoT devices. Now what can we do? If we leverage deception, then we can start monitoring it. We can improve the detection. So we want to do deception, okay? So I made a case here that we need a deception, okay? Now the question comes that, can we just use one type of deception and just wait and watch? It's not going to do, right? We need to have a gamut of things. If we want to make a parallel world along with the real world, it should have all different things. What I mean by that is, like, let's say you got a network which looks like a corporate network. It has workstations, it has printers, and a few web servers. So if you make a parallel world, it should also have workstations. It should also have the web server. It should also have a printer. And it should not be very much different from that. It should adopt the host name, MAC addresses, and all the attributes which belong to that environment. And if it blends with the environment, then it will make the life difficult for the adversary and for the malware as well. And that's the point I want to drive it. Now, along with the blending, there is another thing is, when we make a deception, it has to be contextualized. Let's say if you are a healthcare company, and if I put the same deception there, what is there in the healthcare, and I put the same in the e-commerce company and the payment gateway, it's not going to work. It has to be changing, it has to adapt to that particular environment, that particular network. And even for a same company as well, there are sites which are different. You got operations in Japan, in Asia, you got operations in US, Canada, in India, multiple countries, and they have a different types of networks, hundreds of subnets, thousands of subnets. Now if we want to do this kind of a scalable deception, we need to ensure that it is scalable and also it is contextualized for that enterprise. These are the guiding principle for deception to be effective. Another one is, if you just put the deception there, let's say, whole bunch of these network printers and web servers and databases and also that. I mean, like, these are, it could be the emulated one or the full-fledged VMs, could be anything. But you just can't wait and watch. You need to be more proactive. And then, can we put something at the endpoints? And so breadcrumbs actually provide a way to put it at the endpoints. They give an ability to put the hashes there on the endpoints, and you can piggyback on the agents which are already there, so you don't need to put a new agent there. And then, when the attacker uses the in-memory hash, or he uses the, let's say, a memory, browser memory or browser history, then we can catch it. And the good thing about it, like anywhere we catch adversary, we get this alert. It's a high fidelity alert. Nobody is supposed to do that, right? Obviously, we have already whitelisted the scanners and all that, but once you have done that, you get a high fidelity alert. Now, another thing is we can lure the attacker. We can put a vulnerable share, we can put a vulnerable web server, and that can actually lure the attacker as well, and that will make a lot more interesting. So it is not like we put a deception in a one corner of the enterprise and just forget it. The idea is to have a parallel world, and that world which is much more looks like a real world, and it is much more like understanding the attacker and then playing out that type of deception. Now, as I said, if you want to have it for multiple countries, multiple sites, we need to think about an architecture which is scalable. Now, in this architecture, what we have is, we put a deception, we put a sensor there in one of the site, and then we project this parallel world there, which is a deception form, and it has all the entities over there. So it has all the workstations, servers, which looks like, for that subnet. So when the attacker is doing any scan, it's very hard for him to figure out what is real and what is fake. Another thing is, you say that no, I want to know more about the adversary behavior. I want to understand more about tools and tactics. So can I spin off a full-fledged VM and, let him get into the VM? Well, the trick to do that is, if you put a whole bunch of VMs, it's going to eat away all the resources, right? So you got to do it in a way which is a fluid. So when you get an alert which is a low interaction, you see somebody is trying to do an RDP session, and that time you spin off a VM. And then, you let him in and you study his tools and tactics. So what I talked about, that we need to have an architecture which provides all this scalability and a fluid deception ability. Now, let's say you got an alert, okay, and it's a high fidelity alert. So what do you do after that, right? We can take that alert and do a triage with other events in Splunk, and we can tell a lot more about the threat. We can tell, well, the adversary from which he did a attack, or he launched a malware, or he did a movement, or did a RDP session. Who all were involved there? What are the different users there? What all files were involved there? So let me show you a small demo with that. Okay, so in this demo, what I am showing here is there is a WannaCry ransomware attack which has been done, and we already have a deception already deployed there. So what it does is, like, when the ransomware is doing encrypting the files, that time it also encrypts one of the breadcrumbs, few breadcrumbs, and we have this deception technology there. So when the ransomware encrypts, it encrypts the breadcrumb files as well, and that time we raise an alert. So here the WannaCry attack is being done. So all you see here is that WannaCry is being launched, and it has encrypted the files, and you will see that the ransomware node will get being shown here. So the ransomware nodes showed up, okay? And as I said, that we have a deception in place, so we detect this ransomware incident in the network, and this is the dashboard for a Calvio dashboard, and over there we can see that, okay, there is an event here. There are a bunch of other events, but this particular event here, that shows that the ransomware incident happened, and what was the source IP address from where the ransomware attack was carried out, and then what time it was. So we forward that incident to Splunk, and then we triage with other security events, and we can learn more about this particular incident. So this event is getting forwarded to Splunk, and so we can see a Splunk dashboard equivalent for that. So let's see a dashboard for that. Okay. So this is a one reincarnation of the triage of deception alert and the security events in Splunk. So what you see here is at the top left corner here, we map out all the different incidents into the various phases of kill chain, and then we can investigate those incidents. So this particular one is part of an execution here, this kill chain phase, and then we can also do a sort of like a slice and dice of the data. So here, this particular one shows that, okay, we can group it by the host IP addresses, and we can group it by the different services and the protocols which are being exploited by that hidden threat. In this case, this is more from a ransomware, but there are other incidents also which were there in the network. Now, if you want to study more about this particular incident, so you click on that, and then then you get a lot more information about that particular incident. So you get, okay, what was the source IP address, and so you also get information that, okay, this IP address is also talking to other IP addresses. We use a bro logs, and you use the same delta time, and then write a Splunk query, and then you can find out, okay, what other IP addresses it is this host is being talking. So now we can do a better triage. We can know, okay, if the ransomware is trying to spread, where in which subnets and which part of the network it is trying to spread, because you correlate with the bro logs. Then you also correlate with the user authentication logs, so then you can get the information that, okay, which users are also involved there, so you can know about that. And then also correlate with the vulnerability data as well. Then you can know, okay, which vulnerability has been exploited. Now, if we get all this information, we can do an automated response as well. So this one shows the vulnerability being leveraged for this incident. And then we also show here that, okay, what files being leveraged. So you see the point I'm driving here. When we do a triage of deception alert, since it is a high fidelity alert, we can do a better and effective triage, and then we can do a better response as well, because we have an alert which was a high fidelity, and you started with that. So now all the actions and the response which we do, that can be much more believable and be much more actionable. So let me summarize what we talked about here. We talked about three things. Number one, we can't stop attackers and threats to get in within the network. Obviously, we need something to guard the perimeter. I'm not saying we don't need those tools and tactics, and we need those as well. But let's take it for granted. We can't stop them. They will be, they are there within the network. The question comes that how can we increase the visibility within the enterprise network. And for that, we need to think differently. And we need to leverage something which is there in the nature. And the nature has been using a deception for thousands of years. And it is the backbone of war as well. The t-shirt I'm wearing, this is, the Sun Tzu said also as well that deception is the backbone for the war, and we are at the war. So if we need to win the war, we need to think differently. So deception and AI and Splunk gives us a way to detect hidden threats, to profile them better, and do an automated response. So we have a booth down there on that side, Atlantic B, when you come just next to the escalator. I'll be happy to show you a demo, take your questions. And once again, thanks a lot for coming all the way here. Thank you very much.